Hi everybody, in this video we're going to be having a look at how we can conduct 2D analysis using ANSYS. Okay, I'm just going to come out of this and we're going to start a new static structural. Okay, engineering data, I'm just going to use the standard material, and this is where we can import some geometry. So we're going to import geometry, and I've got a 2D file set up. Sorry, wrong one. I've got this 2D step file, okay, and we can just open up mechanical. And so now we've opened up mechanical, we can see that what we've got is just a surface, okay, within the software. And so this is really useful because it really reduces the amount of processing power that we need to use when we go through the meshing and simulation process. So if I click on the geometry up here, we can see that we've got this little question mark. So this is just basically asking us, it wants to know what the thickness of this material is here. So you can see here it's got 0 thickness at the moment. Obviously to run the analysis we need to assign it some nominal thickness. So I'm going to change this to 10. Okay. Now there is another way in which we can change this. If we click on right click geometry, insert, and then you can see thickness here, and what you can do is you can use this to assign the thickness as well. So if I click on this surface, click apply, I'll just change this thickness to 10. Okay, so if you apply a thickness like this, it will override any thickness that you've predefined in this section here. Okay, so we'll just leave that in place. What we need to do now is mesh it. So we click on mesh, we'll go generate mesh. Okay, so that mesh is not very good at all, it's too coarse. So we're going to manually take control of some of this. So I'm going to go insert and we're going to go sizing. So we're going to select this geometry, click apply, and let's change the default element size to, let's say 4. Let's generate this mesh. Okay, so it's looking better, but I think we can still do a little bit better around this section here. So we're just going to go insert, sizing, and what we're going to do is change it to the edge, and we'll select the edge around here, click apply, and there's different ways in which you can do this. We can change the element size, or we can go number of divisions. So let's change number of divisions, and then let's change this to 30, and then we will generate the mesh. Okay, so that's much better, it's much more refined around the area of interest for us. So now it's literally, we just run it like it's any 3D model. So we can just click on static structural, click insert. So we want a fixed support. Select this edge here, click apply. So that's fixed. Click insert, click force, select this edge, click apply. Let's change this to components, X direction, and we'll change this to 10,000 newtons. Okay, and what we're now going to do is run this. So go solve. Very quick. You can see how quick this solves. And then what we can do now is go insert, and we will have a look at deformation. Let's have a look at directional deformation in X, that's fine. And we'll also insert a stress equivalence. Okay, and we'll evaluate those results. So let's have a look at this. So we've got deformation, we've got the stress, okay. And if we press play, we can see the way that the stress field increases. And if you actually notice, the results are very similar to the example that I used in 3D. Maybe if we could refine it further, we'll get it closer to that 86. But yeah, this is how we run a 2D analysis using ANSYS.